comprehensive LC, I must say, is a more complete separation. So normally, in both technologies, we use a switching valve to divert the fraction from the first column to the second column. And in conventional air cutting system, normally we do this cut 1 or 2 or 3 times, so very few times for the main components, and we transfer normally a peak or sometime a fraction to the second column where our analytes are, and we have a further separation to the second dimension. So the air cutting is applied only for components of interest where we need the further separation. So the difference with the comprehensive LC, as I said to you before, is that all the components coming from the first column are going to the second column. And also another important point is how we visualize the separation. So in comprehensive we use a 2D map where we have in the first axis the separation in the first dimension, in the other we have separation in the second dimension, and we can also use a 3-dimensional visualization where the third dimension is the intensity of the detector. So that is also very important with the food analysis, because when we do comprehensive LC, we do also analysis of very complex samples. For example, in the last years, we were looking for bioactive components in different matrices, and we analyze this sample using orthogonal system. For example, one of the applications we did in our lab is the analysis of triacylglycerols. So triacylglycerols, or a part of the lipid family, they are very complex, and normally we use silver ion chromatography for separating, in conventional LC for separating these components, and the separation is according to the number of double bonds, because the double bonds interact with the silver ion. And or we can also use a reverse phase. So the people working with this field, they know very well that triglycerides are separated according to the partition number. So the partition number is the number of the total number of the carbon minus 2 times the double bond. But unfortunately, these two separation, when we use in a conventional way, they not fulfill the total separation. So the combination of these two is very orthogonal, because the first one, the silver ion, is based on normal phase separation, and the second one is based on reverse phase separation. And just to give you other example, it's, for example, in the carotenoids, they are very important because they are bioactive components. Carotenoids, the same, are very complex because they are components starting from very non-polar, like the carotenes, so hydrocarbon, and going to very, very polar, like the xanthophylls or the free xanthophylls, they are very polar. So the combination of normal phase with the reverse phase is very important, because in the first dimension we separate according to the polarity, and the second dimension we separate according to the reverse phase, so to the hydrophobicity. And so I can give you other example. For example, polyphenols nowadays are very important. For example, polyphenols in wine. In this case, we use an approach where we couple reverse phase with the reverse phase. So we explore different system of gradient. You know, the most common gradient used in comprehensive LC is the full limb fraction. So that means that we repeat the gradient many times for each cut, but at the same gradient level. But we can do also some other type of gradient, like continuous changing of the gradient, or we can do stepping gradient. So we can optimize, even using the same stationary phase, we can use or we can have orthogonality by using reverse phase.